Let's take a look at this example. We're supposed to find voltages between point A and E, voltage between point F and B, voltage between point BD, and voltage between point CB. What we're supposed to do first? Remember, we have to find the total resistance first. This is series circuit, and the formula for series circuit is nothing else, just the total resistance is equal to the sum of all resistances in the circuit. R total is equal R1 plus R2 plus R3 plus R4 plus R5 plus R6 plus R7. So I can say R total is equal R1 2 kilo, R2 5 kilo plus R3, which is equal 3 kilo, plus R4, which is equal 6 kilo, plus R5, which is equal 2.3 kilo, plus R6, which is equal 3.1, plus R7, which is equal 1.2 kilo. Total resistance in this circuit is equal 22.6 kilo. Next, we're supposed to find the total voltage. Anytime you will look for total voltage in series circuit, start always from the strongest power supply. My strongest power supply is 100 volts. This power supply is going to push the current in this direction. So I have positive terminal over here. This one is going to be negative. The longer one is always positive. Short is negative, positive, negative, positive, negative. V total, the strongest one. I'm going to go this way because I use conventional current flow, and this is positive terminal, so theoretically the current is supposed to go up. So I have voltage source 4, and positive terminal goes to the positive. That's why I'm going to subtract voltage source 3, and I'm going to keep going, and again I have positive terminal. That's why I'm going to subtract. Remember, anytime positive goes to positive, you have to subtract voltage sources. So I have voltage source 2, and I have another positive over here. So I'm going to write minus voltage source 1 equals V total is equal voltage source 1 equals 100 volts minus voltage source 3, which is equal 3 volts, minus voltage source 2, which is equal 10 volts, minus voltage source 1, which is equal 20 volts. Answer is 67 volts. Current goes counterclockwise. Anytime you will enter the component, you're supposed to mark this by positive. Anytime you are going to leave, write negative. Positive, negative. Positive, negative. Positive, negative. Positive, negative. Positive, negative. One more time. Why I wrote positive? Because my strongest power supply will push the current in this direction. Anytime current enters the component, you're supposed to write plus. Anytime leaves, you're supposed to write negative. Now, and one more thing, anytime your total voltage is positive, means your strongest power supply is the strongest voltage in the circuit. Anytime you are going to have negative sign, means the current is going to oppose your strongest power supply. It can happen if the sum of the other voltage sources is going to be greater than 100, or let's say value of strongest voltage source. But in this case, my V total is positive, means the current goes in the direction which my voltage source pushes the current. So I have voltage total. Next, I'm supposed to find I total. I total is equal V total over R total, where V total is equal 67 volts over R total, which is equal 22.6 kiloohms. This is equal 2.96 milliamps. This is the total current in my circuit. You're supposed to keep in mind that in a series circuit, the current in each component is going to be always the same. Remember, the KCL says I total for the series circuit is equal to IR1 equals IR2 equals IR3 equals IR4 in this case equals IR5 equals IR6 and is equal to IR7. Next, we're supposed to find voltage across each resistor. So VR1 is nothing else, just I total times R1, where I total is equal 2.96 milliamps times R1, which is equal 2 kilo. So VR1 is equal 5.92 volts. This is voltage across resistor R1. Next, I'm supposed to find VR2. VR2 is I total times R2, which is equal 2.96 milliamps times R2, which is equal 5 kilo. This is equal 14.8 volts. This is voltage across resistor R2. VR3, we're supposed to find I total times R3, which is equal 2.96 milliamps times R3, which is equal 3 kilo. VR3 is equal 8.88 volts. Next, we're supposed to find VR4, which is equal I total times R4, 2.96 milliamps times R4, which is equal 6 kilo. This is equal 17.76 volts. VR5 is equal I total times R5, which is equal 2.96 milliamps times R5, which is equal 2.3 kilo. VR5 is equal 6.8 volts. VR6 is equal I total times R6, which is equal 2.96 milliamps times R6, which is equal 3.1 kilo. This is equal 9.17 volts. VR7 is equal I total times R7, which is equal 2.96 milliamps times 1.2 kilo. VR7 is equal 3.55 volts. I found voltage across each resistor. Before I'm going to continue, I'm going to check if my answers are correct by calculating V total by adding VR1 plus VR2 plus VR3 plus VR4 plus VR5 plus VR6 plus VR7. It's always good to check if your answers are correct before you are going to continue. So simply add all these voltages together. 5.92, 14.8, 8.88, 17.76, 6.8, 9.17 and 3.55. You're supposed to get V total equals 66.88 volts. 66.88 is almost equal to 67 volts. This is the voltage which we obtained at the beginning when we were calculating the total voltage source. Means our voltages are okay so far. Let's continue. These are the voltages which we just found, and this time we're supposed to find a voltage between each point and ground. Please notice that your ground is connected to point C. So this is your reference point. So you are going to measure the voltage between each point respect to this point. First, we have to find VA. We said that the current goes counterclockwise and we are going to have the signs positive and negative, positive and negative, positive and negative. If you want to find voltage A, VA is going to be nothing else just negative VR1. Why negative? Because I'm going to the ground and I'm seeing first negative, and because I'm looking for voltage, I have to take VR1. Next, I'm seeing negative voltage source 2. Next, I have negative VR2. Next, I have negative voltage source 3. Plug in the values. You have negative VR1 we found is equal 5.92. Negative voltage source 2 is equal negative 10 volts. Negative VR2 is negative 14.8 volts. And I have negative voltage source 3 volts, negative 3 volts. Voltage VA is minus 33.72 volts. This is voltage between point A and ground. Next I have to find VB, voltage between point B and point C. I'm going from point B to C. I'm seeing first negative VR2, voltage across this resistor, minus, because I have negative sign over here, voltage source 3. Negative VR2 is equal negative 14.8 volts minus voltage source 3. Minus 3 volts. Minus 14.8 minus 3 volts gives me minus 17.8 volts. This is voltage between point B and C. VC. Point C is connected directly to the ground. That's why voltage at this point is equal 0 volts. VD is the voltage between point D and C. Okay, we said that current goes in this direction, so anytime current enters the component, we have positive sign, anytime leaves, we have negative. So D is nothing else, just the voltage across resistor R3. I have positive sign first, that's why the voltage is going to be positive. VR3. VR3 is equal 8.88 volts. VE is voltage between this point and ground. So what we have first? We have negative voltage source 4. Negative voltage source 4. And I have next positive VR4. And I have positive VR3. Negative voltage source 4 is negative 100 plus VR4 equals 17.76 volts plus VR3, which is equal 8.88 volts. This is equal VE minus 73.36 volts. This is voltage between point E and ground. Next, we're supposed to find voltage VF. VF is positive VR5, and because current goes in this direction, I'm going to write plus VE. Why plus VE? Instead of rewrite these voltages one more time, you're supposed to realize that the current goes in this direction, and I'm going to treat these three components like in one. And I'm going to have positive sign, even if you have negative sign over here, because I'm going to treat this like in one component. So when current goes into it, I'm supposed to write positive. So I'm going to have VR5 6.8 volts plus VE we found is equal negative 73.36 volts, and this is equal positive times negative gives me negative. So I have 6.8 minus 73.36. VF is equal minus 66.56 volts. Next, we're supposed to find these voltages. VAE is nothing else, just voltage VA minus voltage E. VA we said is equal negative 33.72 volts. VE to minus VE is equal negative 73.36 volts. So I'm going to have negative 33.72, negative times negative gives me positive. So VAE is equal 39.64 volts. Remember, negative times negative gives me positive. So I have negative 33.72 plus 73.36 gives me 39.64. Next, we're supposed to find VF B, VFB. This is nothing else, just VF minus VB, where VF is equal minus 66.56 minus VB negative 17.8 volts. Again, negative times negative gives me positive. So I'm going to have minus 66.56 plus, because I have negative times negative, 17.8 gives me negative 48.76 volts. This is voltage VFB. Next voltage, we're supposed to find VBD. VBD is VB minus VD, where VB equals negative 17.8 volts minus VD 8.88 volts. Negative 17.8 minus 8.88 is equal negative 26.68 volts. This is voltage between point B and D. B and D. If you are going to connect voltmeter between these 2 points, you are going to measure this voltage. Next, we're supposed to find VCB. This is nothing else, just VC minus VB, where VC is equal 0 volts minus VB negative 17.8 volts. Negative times negative gives me positive. 0 plus 17.8 gives me 17.8 volts. These are the solutions to my problem.